All right, let's dive right in. Today, we're going to get into some of the most mind-bending ideas in all of physics. But we're not just here to, marvel at them. We're here to ask a really important question. What if some of the biggest, most popular theories out there are actually missing a huge piece of the puzzle?
I mean, come on, we all love these concepts, right? Time travel, a universe that's basically made of tiny pixels, teleportation. It's the stuff that really gets your imagination going. But what if these ideas are kind of like a movie trailer? You know, they show you all the best parts, all the explosions, but they hide the fact that there's no actual plot. What if they're really only half the story? And that right there is the core issue we're going to dig into. See, there's a massive difference between a cool idea that just describes what might be happening and a complete explanation that actually tells us how and why. It's the difference between looking at a blurry, pixelated picture of the world and understanding the full, intricate machinery that makes it all run.
Okay, so let's be totally clear. The ideas coming out of modern physics are absolutely thrilling. I mean, they challenge everything we think we know about reality, and it's no surprise at all that they capture the public imagination.
Just think about it for a second. We're talking about time travel. The idea that space-time itself is broken up into little bits like pixels on a screen, extra dimensions, even teleportation. These are incredible thought experiments. But here's the problem. A lot of the time, they kind of sidestep their main job, which is to actually explain the reality that you and I live in. Which brings us to the main event here, this idea of the missing machinery. So many of these grand theories are great at describing a possible result, but they don't show us the engine. They don't show us the gears, the circuits, the fundamental process that makes it all tick. So when we say machinery, what are we really talking about? Well, it's the how and the why that sit behind any theory. It's just not enough to say the universe does something. A real, solid explanation has to pull back the curtain and show us the underlying process that actually makes it happen. And this quote, man, it just gets right to the heart of it. It's a demand for intellectual honesty, right? It's a call to look past the flashy surface of a cool idea and ask for the deep, nuts and bolts explanation of how it all connects. Okay, to make this a little less abstract, let's look at a specific case study, the idea of discrete realities. This is the theory that everything in the universe is made up of these tiny, fundamental, indivisible units, kind of like pixels on a screen. It's a perfect example of what our source calls a pixelated picture. So right away, this idea brings up some huge questions. I mean, if reality is just a collection of separate little pixels, how do they even talk to each other? What's the force or the mechanism that binds them together to create, well, an arm or a planet or a star? The theory describes the pixels, but it totally forgets to describe the glue. And it goes even deeper than that. How does cause and effect work in a world like this? A model might show you that pixel A lights up and then pixel B lights up, but it doesn't explain why A caused B. That connective tissue of causality, the very engine of how things change, it's just not there. But here is maybe the biggest flaw of all. What about the space between the pixels? Is it just nothing? And if it's nothing, how does any information or force get from one pixel to the next? A complete theory has to describe everything, and that includes the nothing. And, as our source says, this is never done properly. So this is the really crucial takeaway here. If your theory describes a universe of things, but it has absolutely no explanation for the nothing that separates them, then you don't really have a theory of reality. You've just got a list of dots, not a functioning universe. Okay, so what happens when you actually point out these kinds of gaps? Well, often, instead of getting a real answer, you get what our source calls the language of evasion. There's this whole set of rhetorical tricks that get used to defend a theory when its machinery is missing. And there's literally a playbook for it. Step 1. Use a ton of big, intimidating words and jargon to try and shut down the conversation. If that doesn't work, step 2 is to attack the person asking the tough questions. Make them feel like they aren't smart enough to get it. And finally, step 3, just deny there's a problem at all. Dig in and protect the theory no matter what. It's a way to dodge the hard questions. So where does this all leave us? Well, the goal here isn't to just dismiss all these amazing ideas. It's about arming ourselves with better questions. Think of it as a call to action for anyone who's genuinely curious about how the world really works. I really love this quote. It's such a great reminder of what science is supposed to be all about. It's not just about elegant equations or cool concepts.
It is the relentless, honest pursuit of the real machinery of existence. It's about that gritty, determined search to understand how things actually work.
So, I'll leave you with this thought. The next time you read an article or watch a show about some fantastic new theory of the universe, I hope you feel like you can pause and you can ask the most important question of all. Okay, that's a really cool idea, but where's the machinery? Thanks for tuning in.